being good with security was the same as every other performance measure. Development teams got their coding on time. And that's all that mattered. So it didn't become a separate thing anymore. It was built in. And they got the same reward they got for being good developers before.
This is a Security Weekly production. Security Weekly is a resource of Cyber Risk Alliance.
The Cybersecurity Collaborative, in conjunction with Cyber Reason, is proud to present CISO Stories. Each week, CISO Stories takes a deep dive on security leadership. The Cybersecurity Collaborative is a unique membership community enabling cybersecurity leaders to work together in a trusted environment. To learn more, visit securityweekly.com/CSC. I'm your host, Todd Fitzgerald, and this week we welcome Glenn Kapetansky, Chief Security Officer and Technology Capability Lead for Trexan.
Well, I did fall into it. I actually started at Bell Labs long ago, working on a little-known operating system called Unix.
I've heard of it.
And AT&T at that point was 1 million employees. This was the Ma Bell, the largest private company on the earth. And as part of that, it was a government-mandated monopoly that therefore took its privacy concerns very, very seriously. So I was brought up 15 years in how important privacy was and how important it was for companies to protect that privacy. There were 14 volumes of privacy principles that AT&T had built up over 100 years because, and this was way before the internet, they could tell when people were where they were, they would be able to reach out to the single homesteads in the middle of Montana. If there were a problem, they would see that traffic. They would know when mergers and acquisitions were going on, just based on the phone traffic between, say, Dallas and New York. And so privacy had many implications for them. This would now be called insider trading. It would be called personal information. But it was not a matter of law. It was a matter of personal integrity. Later on, I went from AT&T to MCI, which was the second biggest telco at that point, and through various other hops, then went to a .com that held students' information, 16 to 24-year-olds, and we had all 35 of us had to stand up to AOL and Microsoft and their scrutiny that we would be protecting, and worse than that, the students' mothers and fathers, that we were protecting their data properly and so forth. So I just, as time went on, found that the decades of experience in privacy was something that the regulations caught up with, and that was my entry point finally into going into cybersecurity.
I mean, that's pretty amazing that you had 14 volumes of privacy principles back then, and not security principles, but privacy principles.
That's right. I guess if you look at the body of law that GDPR represents, it's pretty big too. But back then it was just principles. And you read the principles, you internalized the principles, and you acted according to them.
Yeah, because we tend to think of privacy today as being this, relatively new phenomenon with all the technologies that have, been in the news. Even though we know privacy laws have been around for quite a while. I think sometimes people think this is something that we're just coming to grips with, but it sounds like you were really at the forefront of a lot of those things.
Well, forefront, I stood on the shoulders of giants, but if you think about it, there are two agencies, AT&T from communications, a decade of phone traffic, and frankly, the three-letter agencies. If you know who called, what, when, where, you got a pretty good idea of what's going on. And these days, you think of that in terms of social media or the internet or network traffic, but that's really just rediscovering and reapplying those same over a century of expertise to the new technology.
Very, very interesting. So it's a great background. I did have stock once in MCI though, so we won't talk about that piece of it, though, Lily.
I'll give
And
you
my
10
and my
bucks.
mother actually had stock in AT&T, and when she passed away, she had the original stock and all the baby bells that had spawned off of that. And so I actually got to see all these companies that were made up of AT&T. It's pretty phenomenal how many companies that were related to that.
It was definitely a twisty tale.
So you wrote an excellent piece around the SDLC environment and how to integrate the SDLC into Agile development. So could you just walk us through, some of those thoughts that you provided in that piece?
So again, back at Bell Labs, we just thought of this as tricks to get things done. This was before Agile, or what's now called adaptive development learning, ADLs. So Agile is just one of them, and there's so many other variants, but they're really only dialects of the same core body that says that you've got, as you set out to deliver something, you need to be adaptive. And a lot of people had a lot of trouble with understanding why I have deep Agile credentials and cyber credentials, but to me, it really is the same. If you don't have enough time and money and resources, then you have to nimbly step through the best decisions you can and be willing to change them daily. So to me, it's the same. And now the industry is catching up. DevOps became DevSecOps, and SDLC became SSDLC. But in a way that kind of hides the message that that good coding, good software is secure software, and bad coding is unsecure. And also, if you don't pay attention to the software development environments, then you're missing truly a major part of your security profile.
So how does somebody go about? I really like that you develop. Developing good code is secure code. And so, how does somebody go about doing that?
So, since I wrote that article, I've actually had to change my thinking a little bit, because it used
we have to redo the book now. Put out a new edition.
We'll save it for the next edition. But it really elaborates on it a little bit, because it turns out that we truly hadn't coded better over like a 5-year window that I was doing the research. The coding vulnerabilities like that allow for man-in-the-middle attacks and the spoofing and so forth, and the bounds checking. Everybody was making those mistakes. Why? I guess maybe there are cost pressures. You always want to get the most junior developer or lowest cost that you could at any one point in time, and those are primarily the ones who haven't learned. So they persist. Now, since that time, there's been a lot of open source code that people pull off the shelf in blocks, and those blocks have been tested, peer tested for security and so forth. So we want to take into account that as well. So I guess the thing that I would add to this is that there is automated tools. There's static code checkers that look for the top vulnerabilities. There's a growing body of frameworks that check open source code, both static and then also runtime for misbehavior. And I think those are important tools to add. You definitely want to automate. It doesn't protect you 100%, but I can 100% guarantee that if you don't use them, you will be unsecure compared to your neighbors.
So is there a sense that adding these tools and these processes, that this is going to slow down the development efforts and kind of defeat the whole idea behind Agile development?
So that's an excellent question, because at the beginning, these tools, like I won't name them by name, but the major tools would return the same somewhat naive thousands of suspected violations and weaknesses when somebody was just trying to put in an update to some web code, and it had already been previously cleared by the previous scans, and it was just coughing up the same ones over and over, and it was definitely slowing things down. So you do have to be intelligent about it. You do have to filter out the false positives. You do have to make sure that you're really only looking at the very tip, the things that require human intervention. But if you do it correctly and you build it in, then it doesn't have to slow you down much. I did have a CIO at a major healthcare payer that just said simply, you have to have a clean bill of health on the static code scanning, or I will not put it in production. And it was incredibly painful for 3 months, 3 cycles of releases. And then it settled down. And as I think about that, the key thing to that was not that the information security organization was some sort of Horatio at the bridge that stood at the very end of checking code that was delivered to it. Those tools were put in the hands of the developers, and the developers made sure that they ran fast and they were efficient and they didn't get in their own way. So I think that principle of empowerment, which is extremely compatible and actually a core tenet in Agile, is the path through it. If you just perceive it as what the inspectors are doing and you kind of complain about it, it will never be efficient. But if you put it in the hands of the people and make them accountable for it, then they will find a way to make it efficient.
So did you find there was any sort of competition between the developers to, get the best, most secure code or not?
No, there wasn't a competition, but people very quickly got a reputation for getting their code in on time compared to others who just complained at the gate and said, not my fault, what am I supposed to do about it? The others who buckled down, just like the interesting thing is at that point, being good with security was the same as every other performance measure. Development teams got their code in on time, and that's all that mattered. So it didn't become a separate thing anymore. It was built in, and they got the same reward they got for being good developers before.
The article this podcast is based upon can be viewed in the best-selling cybersecurity leadership book, CISO Compass, Navigating Cybersecurity Leadership Challenges with Insights from Pioneers, available at Amazon.com and other booksellers. So you had mentioned in your piece about go out to Google and search on the year and vulnerabilities. So could you speak to that a little bit?
Well, I did it myself when I was first joined ThoughtWorks, and besides having the remit for Agile management, which in a way is kind of what we're talking about, the managers themselves have to act differently and more nimbly. I was also asked to head up secure coding and what it would mean to be secure Agile development. And so that's actually the same thinking I went through. I wandered around for a while thinking, and I talked to people, and then I just sat down and did some Googling, and I didn't actually pick the actual organizations, SANS and other major organizations, because I wanted people who read your book, maybe there'll be a really good other organization that'll just come up. But it didn't matter. There was a pattern for those organizations that tracked it year over year, and I just stored the last 5 years, looked at them, and said out of the top 10 vulnerabilities, 7 were the same 5 years running. And as I said, that was a huge. I just went back to ThoughtWorks owner and said, I'm done here because I've reduced it to a problem that you're already working on. You do good coding, you'll have secure coding.
So why do we still have that? I think I saw a while back that like SQL injection was still like 19% of all the vulnerabilities, and so why, if we know this, what are we not doing that we should be doing that we're still getting these same kind of results?
Well, I think there are a combination of factors. One is just simply legacy code. With mergers and acquisitions and so forth, and smaller companies that are less mature get absorbed into larger companies, and it just ends up not being noticed. It's the software version of finding out that the quote unquote data center of a company you just acquired is really a broom closet. And so it just doesn't get noticed. So just in the sheer scale of things and legacy code and just getting by, this stuff just continues through. The second thing is, I think I'd mentioned before that there's a kind of an economic pressure to keep a lower level of expertise running. I do feel that that's changing. I think that everybody's starting gradually to learn this stuff. The third thing is just simply the complexity of things when you're moving between, when you have actually ecosystems of different companies that are actually one large, I don't want to use the word cloud, but it's a connected ecosystem. And you can think of Salesforce, Amazon, marketplaces, and so forth. So the idea of a SQL injection is kind of sort of like the acquisition of a smaller company, but it's also like hidden corners, but it's distributed beyond even the boundaries of a single company. And so therefore the controls and the governance to find them are weakened, if you will. So I think all of these are at play, and that's why I am encouraging the use of automated tools that can just traverse the whole use case and continuously do it, looking for what new thing in some odd corner is now threatening the entire whole.
Well, that's excellent. So what sort of advice would you give to CISOs that are and developers that are starting up their programs or have existing development staffs in place that really want to take it to the next level in terms of, okay, they decide tomorrow we want to be more secure, create more secure code. What sort of things do you think they should be focusing on most?
Well, so I think I come back to a couple of the points in my contribution to your book, which is that just as we've been discussing, the software development process itself, the developers, they need to be made accountable for the security of their code. And I think that's fine. They're made accountable for complying with architectures already. They're made accountable for certain corporate standards. This just adds to it.
What does that accountability look like? Is it a penalty for having so much insecure code, or is it a reward type thing for producing good code?
So we came up with an idea at my current company, Traxon Group, that I think is radically effective, and it's that we take these standards and we express them wherever a company can do agile development. We express them as user stories. And they're technically called non-functional requirements. And it helps because it lets the development team actually not just comply with rules, but understand what the rule is there for. They're always in the form of, in order to achieve such and such, we need to do such and such. So it would actually say, in order to guard against man-in-the-middle attacks, you need to have such and such. And then we would bundle all of those requirements and all those user stories, and we would add them automatically to every new project, along with their other user stories about functions that they have to do for the customer, or for the outside marketplace. And the development team would have to wrestle with that and deal with that in a way that is appropriate for their application. So there's no trying to sidetrack or undercut this checklist item with saying, oh, it's not applicable to us. You tell them why, and then they do testing that complies to the why, and that kind of thing. And then they have to protect. They have to actually present their each one of those stories, what they've done about it, for the product owner. In this case, it could be the CISO or somebody in information security to accept. This allows for all sorts of innovation, but it also encourages compliance. And that also means that they just simply won't be able to deliver their code into production. And the normal punishments in terms of career and job and bonuses, compensation, all fall from that. So we actually think in that side, that's kind of an innovative way to not be the parent of adolescence, somebody who's laying down the law and is somebody that you want to get around. It actually encourages people to think in a secure fashion, applicable to their particular situation. It also gives you some innovation from everybody, and the information security organization go, oh, hey, that's a pretty good idea. We never thought of that, and it allows them to harvest.
So you increase your collaboration across your teams that way, then.
That's right, and it's not adversarial anymore.
Yeah.
The other thing with CISO, so that's the application side, and I did want to touch on the other part, which is these days it really does seem to be that if you pay attention to understanding the identity of who's getting into your systems, protecting your data, and protecting your endpoints, which is kind of related to protecting your data and understanding identity management, and then logging events, you're probably 90% of the way to every compliance and a resilient organization. It's just the era of identity management and data protection, and then just comprehensive logging for everything you might have missed.
I really like that. I like the simplicity of that, of understanding your identities, making sure that you're protecting your data and your endpoints, and then making sure that you log that so that you can take appropriate action. Mm-hmm. I love the simplicity of that. Well, this has been great. Is there anything else that we haven't talked about today? I know we've talked about a lot of great ideas here for secure development. Anything else that you'd like to share?
Well, I think you managed to draw everything out that I wanted to get out in terms of software development. I really just wanted people to understand that it's not so tough. It can be everybody's job. It doesn't have to be you alone that does it. You don't have to understand everything. You don't have to be up to date on everything. You create a whole ecosystem. It's like that old, it takes a village. If you look at it the right way, then everybody's working with you and you end up with a secure software, secure application, secure product, and secure environment.
Well, I really like that. Well, Glenn, it's really been a pleasure to talk with you today, and thanks much for your excellent contribution to the CISO Compass book.
Well, Todd, thanks for inviting me.
Thank you.
Cybereason is the champion for today's defenders, providing an endpoint security platform to prevent, detect, and respond to malicious operations on computers, mobile devices, servers, and the cloud. Cybereason. End cyber attacks from endpoints to the enterprise to everywhere. Learn more at cybereason.com/CISO stories.